Okay, now this looks different from the standard question. Let's have a look at this now. It says the lines L and M have these equations. Relative to the origin O, the position vector of the point P is 4i plus 7j minus 2k. So we've got this point P, the position vector of the point P, OP, that is 4, 7, and minus 2. And the position vector of, we have lines equations as well. Given that L is perpendicular to M and that P lies on L, find the values of the constants A, B, and C. Okay, lines L and M are perpendicular to each other. Okay, now if two lines are perpendicular, that means their direction vectors are supposed to be perpendicular, right? Because perpendicular has something to do with the angle of those lines. Angles come from the direction vectors. Okay, whenever we talk about two lines being perpendicular, we're basically saying their direction vectors are supposed to be perpendicular. What are the directions of the line? Let's write them in vector form and the column vector form. They are C minus 2, 4, and 2, minus 3, and 1. Since they are both perpendicular, the dot product of their direction vectors, that should be equal to 0. What do we get from this? 2c minus 2 into minus 3, that's 6, plus 6 plus 4, that equals 0. And that gives us the value of c, which is minus 5. So we get the value of c from this using that both the lines are perpendicular. That's one thing. And now it says point P lies on L. What's the equation of the line L? The equation of the line L is this. It's R equals, let's write this in column form again. It's A, 3, and B plus lambda into C. We've got the value of C now. The value of C is minus 5, minus 2, and 4. This is the equation of the line L. Since the point P lies on L, if we were to input that point P in this equation should satisfy, right? If you were to input the position vector of P inside this line, this equation should be satisfied by that. Let's do that. Let's put that point here. What's the point? It's equated to that point, 4, 7, minus 2. Right? In place of R, we input that point. On the right side, let's simplify this. We have A minus 5 lambda, 3 minus 2 lambda, and B plus 4 lambda. Just equate them and see what that gives you. A minus 5 lambda equals 4. That's one equation. 3 minus 2 lambda equals 7. And B plus 4 lambda equals minus 2. Let's find the value of lambda from the middle one, because there we only have one unknown, that's lambda. What does that turn out to be? Lambda here turns out to be minus 4 over 2, which is the minus 2. Put that value of lambda here and here, and that will give you the value of A and B. A minus 5 into minus 2, that equals 4. The value of A turns out to be, let me do one more step. A plus 10 equals 4. That means A equals minus 6. And then in the other equation, B plus 4 into minus 2, that equals minus 2. That means B minus 8 equals minus 2. And the value of B turns out to be plus 6. So A equals minus 6, B equals 6, and the value of C equals minus 5. These were the three values that we were looking for. Okay. We got the values of A, B, and C. That was the first part. So for A and B, we just put that point P inside this equation. All right. Okay. Now, let's look at the next part. The next part says the perpendicular. Why we're doing this, by the way, just a reminder, what does this R represent? R basically represents X, Y, Z, right? Just like in a straight line equation in 2D form, let's say you have 2x plus 5 here, X and Y are representing every single point on the line. So R here is basically X, Y, Z. It represents every single point on the line. So if P lies on this line, in place of X, Y, and Z, we basically just put these values. Okay? All right, good. Let's have a look at the next part now. Now it says the perpendicular from P meets the line M at Q. The point R lies on PQ extended with PQ ratio QR being 2:3. Find the position vector of R. Okay, now how do you think about this? Perpendicular from P meets the line M at Q. Okay. So we have a point P somewhere. Let's say this is point P. Do we know the position vector of the point P? 4, 7, and -2. That's the position vector of P. 4, 7, -2. And then we've got the line M. The line M has this equation. Let me write that down here as well. R equals 1, 2, 3 plus mu into 2 minus 3, 1. 2 minus 3 and 1. That's the line N. And now they're saying the perpendicular from P meets the line M at Q. So if you were to make a perpendicular from P to the line M, this point here, the foot of the perpendicular, they're calling this point Q. And now they're saying the point R lies on PQ extended, such that PQ ratio QR is 2:3. Okay, so basically, if you were to extend this line further, at some point you've got another point that's R, and that is such that if this was 2 units, this would be 3 units. That's what they're saying. Okay? If PQ was 2 units, QR would be 3 units. And now, based on this information, we need to find the position vector of R. Now, how do we do this? First of all, we have to find the position vector of the point Q. Once we have the position vector of the point Q, we can use ratios after that to figure out the point R as well. Okay, so we need to start by finding the position vector of the point Q first of all. How do we do that? Let's think about this. Okay, let's find the position vector of the point Q and see what that turns out to be. It's the same process that we did for the earlier question, the vector question in the last paper as well. Let's follow that same process again quickly. First of all, we need to find the vector PQ somehow. How do you find the vector PQ? For that, we need OP and OQ. OP is already given. What's OQ? OQ is going to be of the same form as the equation of the line. Since OQ lies on the line M, the position vector of Q is going to be the same as this line, because it lies on this line. It's just that we don't know what the value of mu is, so we write this in terms of mu. It turns out to be 1 plus 2 mu, 2 minus 3 mu, and 3 plus mu. That's the vector OQ. Okay, and now let's find the vector PQ. What would that be? PQ would be OQ minus OP. So from this vector, I'm subtracting this vector. Let me do that directly now. 1 minus 4, that will be minus 3 plus 2 mu. This minus 7, 2 minus 7 is minus 5, minus 3 mu. 3 minus minus 2, that's 3 plus 2, that's 5 plus mu. This is the vector PQ. And now since PQ is supposed to be perpendicular to the line M, what we can do now is we can put the dot product of PQ, that's minus 3 plus 2 mu minus 5 minus 3 mu, 5 plus mu. Dot product of this with the direction vector of the line M, that's this. So basically we're using this vector here, the direction of line M, and the vector PQ. Their dot product is supposed to be 0 because they're perpendicular to each other. 2 minus 3, 1, that's the direction vector of the line M. Their dot product has to equal 0. Okay, let's find this dot product. Minus 3 into 2, that is going to give us minus 6. 2 mu into 2, that is 4 mu. Minus 5 into minus 3, that's plus 15. And then we have plus 9 mu plus 5 plus mu. This equals 0. Let's simplify this and find the value of mu from this and see what that turns out to be. We get 14 times mu and 20 minus 6, that's also 14, plus 14 equals 0, and the value of mu turns out to be negative 1. We found the value of mu. We can use this now to find the position vector of the point Q. This is OQ. Let's write down that position vector. So in place of mu, we have to input negative 1. Okay, so what does this become? You can just write it here. 1 plus 2 into minus 1, 2 minus 3 into minus 1, and 3 minus 1. That will be 1 minus 2, which is minus 1. 2 plus 3, that's 5. And 3 minus 1, that's 2. So the position vector of Q turns out to be this. We've got the vector OQ. All right. So we have OP and we've got OQ. Now we need to find the vector OR somehow. How do we do that? Let's think about this. Let me write this here now. So there could be another formal way of doing this, but you can actually just think of it logically. Let me explain how. Let me write it like this to save some space. OP, that vector OP is given by 4, 7 minus 2. And then you have OQ. OQ is minus 1, 5, and 2. How do we go from P to Q? In order to go from P to Q, how many units do we have to go here? Minus 5 units, right? 4 to minus 1. How do we go from 4 to minus 1? We have to subtract 5 units for that. In order to go from 4 to minus 1, we have to go minus 5 units. Okay. You in PQ? Why would we do that? If we put mu in PQ, that is going to be used for finding the length of PQ, but we don't need that. We want the position vector of R. We're looking for this point R. What you are saying is that's used for finding the distance PQ, that we put mu in PQ and then find the modulus of that, magnitude of that to find the distance of P from Q. That's not what we're looking for. We're looking for the position vector of point R. And that's this one. We've got point P and point Q now. How do we go from P to Q? In order to go from P to Q, we have to go minus 5 units, right? And then in order to go from 7 to 5, we have to go minus 2 units. In order to go from minus 2 to 2, we have to go plus 4 units. And they are saying distance from P to Q is basically 2 if the distance from Q to R is 3. So basically, the ratio between these distances is 2:3. So if this gap is 2 units, this gap is supposed to be how much? 3 units. Or if this gap was 1 unit, this gap is 1.5 units. So essentially, whatever is the gap earlier, you just multiply that by 1.5. So in order to get to point R now, what you have to do is minus 5 into 1.5, that's minus 7.5. Minus 2 into 1.5, that's minus 3. And then 4 into 1.5, that's plus 6. You have to go this many units more to get to the point R. And that point R, therefore, would be minus 1 minus 7.5, that is minus 8.5. Minus 2 minus 3, that is minus 5. And 2 plus 6, that is 8. This should be the position vector of the point R. Okay, sorry, 5 minus 3. That is actually, this was 5 minus 3. That's actually 2. Minus 8.5. Let me check this again. Minus 1 minus 7.5. That's minus 8.5. And then 5 minus 3. That's 2. 2 plus 6. That's 8. And that is the result that we get from this. This is one way to think about this. If you understand this, that's great. It requires a lot of thinking. The other possibility is slightly simpler to understand. Let me actually explain that as well now. Since PQ ratio QR is 2:3, we could also do something like this. We could say the vector PQ and the vector QR, let's connect both of them. How can you connect both of them? PQ and QR. If the ratio is 2:3, we could write it like this. We could say PQ over QR, that equals 2/3. And if we cross multiply, that gives us 3PQ equals 2QR. If this is the ratio of their magnitudes, it would be the same ratio for their vectors as well. So we could say 3 into PQ vector, that would be equal to 2 times QR vector. And now, since we already have PQ vector here, that's here. Let's see what this turns out to be. If mu is minus 1, what do we get for that? Minus 3 minus 2, minus 5 plus 3, and 5 minus 1. That will be minus 5. So this vector is minus 5, minus 2, and 4. Minus 5, minus 2, and 4. That equals 2 into QR vector. Now we don't know what QR vector is. In place of QR, what we can do is we can say QR is the same thing as OR minus OQ. And now on the left side, we've got minus 15, minus 6, and 12. On the right side, we have 2 into OR. OR is what we have to find out. Minus 2 into OQ. What's OQ? OQ we'll already know. OQ is this vector. What was this? We found this here as well. Minus 1, 5, and 2. Minus 1, 5, and 2. Minus 1, 5, and 2. And now we can find OR from this. Let's see what that's going to be. Minus 15, minus 6, 12. Let's bring this to the other side. It becomes plus 2 into minus 1, 5, 2. That equals 2 into OR vector. Now this becomes minus 17, 4, and 14 on the other side. Sorry, that's not correct. Minus 6 plus minus 6 plus 10. That's 4. That's correct. This was 12. You can write this clearly. 12 plus 2 into 2, that will be 16. Yeah, that's also correct. On the right side, we've got 2 into OR vector. Now divide the other side by 2. So we have 1 over 2 times this now. And that will give us the vector OR, which turns out to be minus 8.5, 2, and 8. And that's the same thing that we got there as well. That's the vector OR. That's another way to think about this. Okay. All right. So this is the last question that you're asking about from this paper, question number 11. Let's have a look at this now. In the diagram, OABCD is a solid figure in which OA equals OB, and both of them are equal to 4 units. And OD equals 3 units. OD. Okay, so OD equals 3 units. This length is 3 units. And OA and OB, these lengths are both 4 units. So you can actually write down the vectors OA, OB, and OD from this. OA has I direction, so you can say the vector OA, that equals 4 times A, right? I is the unit vector in this direction. If the length is 4, it becomes 4I. OB vector has a length 4 and direction J, so it becomes 4J. And OD vector has a length of 3 units and direction K, so that's 3K. These are the 3 vectors that we have. Now it says the edge OD is vertical. Okay, so OD is vertical. DC is parallel to OB. All right, now that looks slightly complicated. DC is parallel to OB, so that's parallel to this length here. Keep that in mind. This is parallel to this side. And DC is equal to 1 unit. DC is 1 unit. If DC is 1 unit, now it will help you later on if you keep writing down these vectors. DC is parallel to OB. That means it's in the same direction as OB. So its direction is basically J. And its length is 1. So that means the vector DC is 1 times J. That's just J. DC vector is J. Okay, 1 times J, that's J. Now, the base OAB is horizontal. So this base is horizontal. OD is vertical. Keep that in mind. Angle AOB is 90 degrees. AOB. So this angle is also 90. Now this angle is 90, and remember, OD is vertical. So the angle of OD with OA will be 90. Angle of OD with OB will also be 90. So all of these are 90 degrees angles, right? Because OD is vertical and AOB is horizontal. So keep that in mind. All right. Now, the midpoint of AB is M. You can see that in the diagram as well. This point is M. And the point N on BC is such that Cn equals to 2 times NB. Cn is 2 times NB. So if this length is 2, this length is 1. Now you see, it's a vector question with these ratios. It generally gets pretty lengthy. Again, a question not to touch in the middle of the exam. Okay, sometimes vector questions are relatively straightforward, like finding points of intersection, finding perpendicular distance, standard methods. You can just apply those standard methods and get the results. Sometimes it's more complicated, like this one, where you have to use ratios, etc. This is going to become quite complicated. Do not end up starting this in the middle of the exam, okay? Otherwise, you will be losing a lot of time. Keep this for the end. Okay, now, Now, not always just this vector question, this type of vector question, because this is going to take longer. Sometimes you get an easier vector question. You should definitely do that. Do not skip that in the middle, because mostly the vectors questions are pretty standard, right? Finding points of intersection and stuff. You should be doing those in the middle of the exam as they come, basically. Okay, now how do you find these vectors? One vector that you have to find is vector MD. So you have to start at M and end at D. So from M, we have to go to the point D. Let's find a path on the diagram on which we know some vectors. We can go from M to A. Now we have to find this vector first. Then we can go from A to O and then from O to D. This is one possible path that you can follow. There could be other possible paths as well, but this is one possibility. Okay. In order to go from M to D, you can say, let's go from M to A and then go from A to O and then go from O to D. Now, AO is known. That will be minus 4i. OD is known. The only problem is MA. Now, M is the midpoint of AB. So we can say MA is half of BA. If we consider this whole vector BA, MA is going to be half of that. So it's half of BA plus AO plus OD. And now what is BA? BA is basically OA minus OB, remember? Position vector of the second point minus the position vector of the first point, OA minus OB, plus AO plus OD. Now just write down those vectors and simplify them. That's 1/2 into OA. What's OA? O to A was 4i. So we have 4i here. Minus OB, that was 4j. Plus AO. AO will be negative of this. That's minus 4i. So you have minus 4i plus OD. OD is 3k. This is the vector MD. That was one thing that you were looking for. Let's simplify this. 4i/2, that's 2i minus 2j minus 4i plus 3k. When you simplify this, that gives you minus 2i minus 2j plus 3k. That is MD vector. Okay, that is one thing that we were looking for here, the vector MD. All right. Now the second thing that you're asking us for is ON. So now on the diagram, we have to start at O. How do we know that the direction is BA and not AB? Because we are starting from M, right? We're going from M to A. From M to A, it's this direction, right? Towards the left side, MA. That's the vector that we're using here. What's the vector parallel to that in the same direction? It's BA in the same direction, starting from B, ending at A. So it's not AB, it's BA. All right, towards the left side. Okay. All right, that's the vector MD. Now the other vector that we're looking for is ON. So we need to start at O and end at N. Now, what path can we follow for this? We can say, let's go from O to B and then from B to N. This is one possibility, right? Let's do that. ON vector equals OB plus BN. Now, OB is known to us, that is 4 times J. The problem is BN. Now, since we know the ratio of these sides, we can say BN is the same as some number multiplied by the vector BC, right? BC in the same direction. BC is parallel to BN. So we can say BN vector is 1 over 3 times BC vector, right? Because we know the ratio. If this total length was 3 units, if that total length is 3 units, Bn is 1 out of those 3 units. So we can say Bn vector is 1 over 3 of this whole vector BC. Right? It's 1 over 3 times that vector BC. And now, can we find the vector BC somehow? What is BC going to be? Position vector of the second point. That's OC minus the position vector of the first point. That's OB. Now, both of these vectors are known to us. We can say that's 4j plus 1 over 3 into OC. OC was, do we know OC? Okay, now we also do not know OC. How do you find OC? You can go from O to D and then from D to C. Let's write that down here. OC vector is OD plus DC. We know both of them. OD is 3K and DC is J. So OC is 3K plus J. Let's put that here. 3K plus J minus OB. What's OB? OB is 4 times J. Subtract that here. And that's going to give you the vector ON. Let's simplify this. That gives us 4J plus 1 over 3 multiplied by 3K minus 3J. Simplify this. And that gives you 4J plus K minus J. And it's 3J plus K. That's the vector ON. That's what we were looking for here. All right. Make sense? Now, that's a bit complicated, requires some practice, but once you practice this enough, it's very similar to O-level vectors, basically. In O-levels, you used to have 2-dimensional figures. It's just that here you have 3-dimensional figures. Okay, you just have to find a path on the diagram that takes you from the starting point to the end point. Okay, so that's how it works. Now, keep in mind, mostly, not always, mostly when they ask you for vectors like these, the coefficients here are integers. Now, not always, sometimes they are fractions as well. That is possible. But mostly, these are integers. So if you're getting fractions, make sure to just recheck your working in case there is some careless error here. Okay? All right, now let's move on. Calculate the angle in degrees between the directions of MD and ON. Angle between directions MD and ON. Okay, so we found both of those vectors before. Now you see the next 2 parts are pretty standard, right? The next 2 parts are standard, but you can only do them if you get the first part correct, right? Now vector MD is equal to minus 2i minus 2j plus 3k, and the other vector ON, that is equal to 3j plus k. Okay, we need to find the vectors, the angle in degrees between these 2 directions. Just apply the angle formula. What's the angle formula? Cos theta equals A dot B divided by modulus of A into modulus of B. Just apply that formula. What's the angle? The angle here is cos theta equal to, in fact, you can just find those 2 things that we need here first. Dot product. What's the dot product? Let's find that dot product first. Just multiply corresponding components. It becomes minus 2 into 0. There's no I component here. Plus minus 2 into 3, the j components. Plus 3 into 1, the k components. A dot B turns out to be minus 6 plus 3, which is minus 3. That's the dot product. Let's find the magnitudes. For this first vector, I'm calling this vector A and this vector B for the formula. Now this becomes 2 squared plus 2 squared plus 3 squared, and then square root of that. This is going to be square root of 9 plus 8, which is 17. And then you do modulus of B and see what that turns out to be. Modulus of B is 3 squared plus 1 squared, and that gives us under root of 10. Let's input these values here. It becomes cos theta equals -3 divided by under root of 17 into under root of 10. Put this on your calculator directly. You'll get an obtuse angle for this, and that's all right. You can write this as an obtuse angle as well. That's perfectly okay. Or you can write the corresponding acute angle. Both of them are acceptable. Let's see what we get for this. -3 divided by under root 17 multiplied by under root 10. And this gives us minus 0.23 something. Cos inverse of that, that's giving me 103.3 degrees. Make sure your calculator is in degrees mode here because the question requires your answer to be in degrees. Again, that's your final answer. Now it says, show that the length of the perpendicular from M to ON is under root 22/5. Perpendicular distance from a point to a line. From a point to a line. Remember the method for that? You just have to apply that standard method, all of that, and that will give you the result. Okay. Now, what do you need for that? You need the position vector of the point M. Do we have that? OM. You need the point's position vector, OM. Do we have that anywhere here? Well, we don't. We have to find the vector OM first. The position vector of the point M. We can say that's OA plus AM. OA plus AM. And then it becomes OA plus half of AB. AM vector is half of AB vector. We know AB vector. OA is, in fact, there's a direct way of doing this as well, by the way. I'll also show you that way. OA is 4i. And then AB is OB minus OA. OB is 4 minus 4i. 4j minus 4i. That's going to give you the result. It becomes 2i plus 2j. That's what OM turns out to be. A direct way of doing this could be, since M is the midpoint of A and B, you could use the midpoint formula as well here. Right? M is the midpoint of A and B. The midpoint formula. Let's see what that gives us. The direct way of doing this could be using something like this, that OM is half of OA plus OB, right? It's the midpoint of A and B. OM, the position vector of the midpoint, that can be written as half of OA plus OB. And that will also give the same result. OA was 4i and OB was 4j. And that also gives you 2i plus 2j. So you could also do it this way. Okay. Now we have the vector OM, the position vector of the point M. That's one thing that we wanted. We wanted distance from ON. Now let's think about this. Let's say this is ON. This is the line ON. And there's a point M somewhere. We need to find this distance, the perpendicular distance between that point and this line. Now for that, we also need the equation of the line ON. We need to find this equation somehow. Equation of the line ON. How do we do that? We need a point that lies on this line. We know the point N. What's the position vector of the point N? We found that earlier. 3j plus k. Now for equations, I prefer using the vector, the column vector form generally. That seems easier to me. So it's 0, 3, 1. And OM vector is 2, 2, 0. We've got the point M. Now, what's the equation of the line N? Line ON. What's the equation? R equals A plus lambda D. A means a point on the line. This is a point on the line, the position vector of a point on the line. That's 0, 3, 1. And now if you think about it, or you could actually also use origin, because origin is also a point. This is also fine. 0, 3, 1, you could also use this. But to make things simpler, in place of the point, you could actually just use origin, right? Because ON, the line ON, also passes through origin. So it's easier to just use origin here. So this is the point, R equals A plus lambda D. So 0, 0, 0 plus lambda into D. What's the direction vector? This is the direction vector. That's 0, 3, 1. A plus lambda D. That's what we're using here. That's the equation of the line. This turns out to be lambda into 0, 3, 1. That's the equation of the line ON. We've got the equation of the line ON. We've got the position vector of the point M. Now, what we used to do after this? We need this point. Position vector of the foot of the perpendicular. Let's call this point something. Let's call this point X. What is point X going to be? The position vector of the point X. You can say OX vector. That's the position vector of the point X. X lies on this line ON. What's the position vector of the point X? The same as this line. And that will be 0 lambda, which is the 0, 3 lambda, and 1 lambda. This is OX. You could simplify this to 0, 3 lambda, and lambda. That's the point OX. And now we need to find the vector MX somehow, because vector MX is supposed to be perpendicular to the direction of the line L. And we would equate their dot product to 0. What's the vector MX? Let's find that. Vector MX is going to be OX minus ON. That gives us 0 minus 2. Or let me actually just write that. 0, 3 lambda, lambda minus 2, 2, 0. The vector MX therefore becomes minus 2, 3 lambda minus 2, and lambda. That's the vector MX. Now that we've got the vector MX, we say that MX is supposed to be perpendicular to the direction of this line. What's the direction of the line? ON. So now we can use that idea that MX vector is perpendicular to ON vector. Just put their dot product equal to 0. Minus 2, 3 lambda minus 2, and lambda. Dot product of that with the vector ON. What was the vector ON? The direction of the line ON. That's 0, 3, 1. This should equal 0, right? Because they are supposed to be perpendicular vectors. What do we get from this? Minus 2 into 0 plus 3 lambda minus 2 into 3 plus lambda into 1. That equals 0. And that gives us 9 lambda minus 6 plus lambda equal to 0. We would get a value of lambda from this, which is 6 over 10, and that's 3 over 5. That's the value of lambda at which the point X would be a perpendicular. Now, what we're looking for is this distance from M to this point X. This distance, that's what we're looking for. Now, we already have the vector MX. All we have to do is put the value of lambda in that. What does the vector MX become now? Vector MX becomes minus 2, 3 lambda minus 2 lambda. Let's input that value of lambda in this. lambda equal to 3/5. What do we get from that? -2. 3 into 3/5 -2. That's giving me -1/5, and then 3/5. That's the vector mx. Now you find the magnitude of this vector, because that is going to give you that distance. What's the magnitude of this vector? Square root of -2 whole squared plus -1/5 whole squared. In fact, you can just use positive values as well if you want, because it doesn't make any difference. 2 squared plus 1/5 whole squared plus 3/5 whole squared. That is going to give you that perpendicular distance. Now, do they want an exact answer? Okay, so they want you to show that it's under root 22/5. Let's simplify this. 2 squared, that's 4 plus 1/25 plus 9/25, and that is 22/5. Inside the square root, you get 22/5, and that is what they wanted you to prove. That's the perpendicular distance. Now, that's a standard method. You have to understand that very well. Finding perpendicular distance from a point to a line, it's complicated, but once you understand it, you just have to apply that same method on such questions. To this, with respect to the original, the point A has position vector given by OA, which is iota, it's not iota, I plus 5j plus 6k. This is a vector OA. Then we have a line L that has vector equation R equals 4i plus k plus lambda into this. Find in degrees the acute angle between the directions of OA and L. Acha, OA vector to aapko pata kya hai? OA vector is 1, 5, and 6. All right. What about the direction of the line L? This is the direction, right? That is -1, 2, and 3. Now, how do we find angle? Vector में आपके पास vectors में आपके पास एक ही formula होता है angles का, cos of theta, that is equal to a dot b divided by modulus of a into modulus of b. ठीक है, इसके अंदर values input करनी है आपको, simply dot product. वो क्या आएगा? 1 into -1 plus 5 into 2. You should show this working, plus 6 into 3. That's the dot product divided by the modulus. 1 squared plus 5 squared plus 6 squared, ये first का modulus, और दूसरे का 1 squared plus 2 squared plus 3 squared. Okay, अभी हमें evaluate करना है. Right side पे देखते हैं हमारे पास क्या आता है. Numerator is going to give us -1 plus 10 plus 18. So that's 28 minus 1, which is 27. And the numerator, and the denominator, we have square root of 36 plus 26, which is 62, square root of 62. And the second modulus is square root of 14. Okay, cos inverse निकाल लें. देखें आपके पास थीटा की वैल्यू क्या आती है. डिग्रीज में चाहिए आपको. So calculator should be in degrees. Acute angle चाहिए. इससे आपको acute ही मिलेगा because dot product positive है. तो डायरेक्टली acute angle मिलेगा. अगर आपके पास obtuse angle आ रहा होता तो क्या करते हैं, 180 में से माइनस कर देते, and that would give you the corresponding acute angle. Okay, cos inverse. Now you make sure that your calculator is in radian, is in degrees mode first of all. Let me change that. Cos inverse of 27 divided by square root of 62 and square root of 14. And this is giving me 23.59. So that's 23.6 degrees. That's the angle that we were looking for here. Okay, so that was pretty straightforward. Yeah, apne angle figure out karna tha. Okay, let's move on to the second part. It says find the position vector of the foot of the perpendicular from A to L. Now this is a standard question. It's the same working है, वो आपको एक तरह से याद ही होनी चाहिए working. It's slightly confusing, but you have to memorize this working, right? Because this is a standard question that comes every other paper. Foot of the perpendicular find करना, perpendicular distance find करना, उनकी बहुत similar working है. Now, how is this going to work? आपके पास एक line की equation है. Line क्या है? Let me write that here. In fact, एक point OA है. Let me write that point here first of all as well. That's 1, 5, and 6. and the line L is R equals, write this in vector form, 4i plus k, j component missing है, so that's 401 plus lambda into minus 1, 2, 3. This is the equation of the line that we have. ठीक है? Okay. अब हम क्या करेंगे? हम कहेंगे अच्छा एक line L है, इस तरह से line L है, there is a point which is point A that may be somewhere here. इससे एक perpendicular आ रहा होगा यहाँ पे, ये जहाँ पे इसको मीट करता है, that's called the foot of the perpendicular. ये point X है, X का आपने position vector find करना है. Now X is a point that lies on the line L. L के ऊपर lie करता है, तो X का position vector किस form का होएगा? वो line L की equation की form का ही position vector होएगा. ठीक है? जो line L की equation है, उसी form का आपका point X का position vector होएगा. Let me just change the positions here. ताकि उसका नीचे पर लिख लें. ये आपकी line की equation है. क्योंकि point X line के ऊपर lie करता है, जो X का position vector होगा, वो क्या होगा? That's going to be of this form, 4 minus lambda, 0 plus 2 lambda, that's just 2 lambda, 1 plus 3 lambda. Okay, OX is going to be of this form because this line represents every point on this line. This equation represents every point on the line L. X is a point on the line L. So X ka position vector bhi usi form ka hona chahiye, right? So that's OX. And now what we do is we say, let's find the vector AX using this. AX vector kya ho jayega? AX vector is equal to OX minus OA. What's the vector OX? OX हमने ऊपर लिखा है अभी, that's 4 minus lambda, 2 lambda, 1 plus 3 lambda. We subtract from this OA, which is 1, 5 and 6. इससे हमें क्या मिलेगा? AX vector मिल जाएगा. ये क्या आता है? 4 minus 1 is 3, so that's 3 minus lambda, 2 lambda minus 5, and 1 minus 6 is minus 5, so that's minus 5 plus 3 lambda. This is the vector AX. ठीक है, हमारे पास AX vector आ गया. Now, since the vector AX and the line L are perpendicular, हम क्या कहेंगे? AX vector is perpendicular to the direction. Remember, perpendicular का ताल्लुक जो है वो आपका direction vector से होता है. Angle जो है वो डायरेक्शन पे डिपेंड कर रहा होता है. सो AX वेक्टर जो है वो डायरेक्शन ऑफ L के परपेंडिकुलर है, तो इनका डॉट प्रोडक्ट 0 होना चाहिए. व्हाट्स AX? AX is 3 minus lambda, 2 lambda minus 5 and minus 5 plus 3 lambda. इसका डॉट प्रोडक्ट लाइन की डायरेक्शन वेक्टर से, which is minus 1, 2 and 3. this one, ये 0 होना चाहिए. minus 1, 2, 3. ये डॉट प्रोडक्ट जो है हमारे पास 0 आना चाहिए. इसको 0 से इक्वेट कर दिया. All right. Now let's evaluate this. 3 minus lambda into minus 1 plus 2 lambda minus 5 into 2. यहाँ पे साइन के बहुत एरर्स होते हैं स्टेप के अंदर. Make sure that you're using proper brackets. ब्रैकेट सही तरह से यूज करनी है, सब कुछ ब्रैकेट में डाल के लिखना है, फिर उसको सिंप्लीफाई करना है. Let's simplify this. It gives us minus 3 plus lambda plus 4 lambda minus 10 minus 15 plus 9 lambda equals 0. Let's simplify this and see what we get from this. 14 lambda minus 28 equals 0, and the value of lambda turns out to be 2. Lambda 2 आ गया. अब OX का जो वेक्टर था उसके अंदर lambda की जगह 2 डाल दें, आपके पास वो वेक्टर आ जाएगा. So OX वेक्टर क्या था? 4 minus lambda, 2 lambda and 1 plus 3 lambda. ये आपका OX था, X का position vector. इसमें lambda की value 2 डाल दें, you'll get the position vector of the point X, which is the foot of the perpendicular, and that's what we were looking for. 4 minus 2 is going to give us 2. 2 into 2 is going to give us 4, and 1 plus 3 into 2, that gives us 7. This is the position vector of the foot of the perpendicular that we wanted. Okay, this is your final answer. Okay, now in the last part it says, hence find the position vector of the reflection of A in the line L. Reflection of A in the line L. How do you find that now? you have this line L. You have a point X here. This position vector find 𝗪𝗃. You have a point A here. What you have to find is the reflection of the point A in this line. So that may be somewhere here. Let's call this A dash. This is what we're looking for. आपको X का position vector पता है, right? ये क्या था? X का position vector कितना था? हमने यहाँ पे find किया 247. X is 247. So यहाँ पे हम side पे लिख लेते हैं. In fact, we know OA vector is 156. ये ऊपर लिखा हुआ था. And OX vector is 247. One way of thinking about this is कि आप देखें आपको A से X पे जाने के लिए क्या करना है. देखिए ये एक तरह से उसके कोऑर्डिनेट्स भी आप समझ सकते हैं. अगर आप कोऑर्डिनेट्स फॉर्म में लिखें, ये A के कोऑर्डिनेट्स हैं, ये आपके X के कोऑर्डिनेट्स हैं. तो A से X पे जाने के लिए आपको क्या करना पड़ता है? A से X पे जाने के लिए, if I were to write it like this, 156, इससे आपको X पे जाने के लिए क्या करना पड़ता है? You have to add 1 to the X component, you have to subtract 1 from the Y component, and you have to add 1 to the Z component. यही चीज आप आगे भी कर रहे होंगे. Add 1 to the X component, subtract 1 from the Y component, add 1 to the Z component, and that is going to give you 3, 3, and 8. And that is the position vector of the reflection that you have. इसका position vector ये हो जाएगा. You have this integration. You have to use integration by parts here. In the second part, I think, for finding the area. And the first part is just differentiation. We use the product rule here. Again, not that difficult. Question number 11. These lines intersect. Find the value of A and the position vector of the point of intersection. Now they're saying, given that the two lines intersect, what that means is, when you equate the two equations, you would get 3 equations from that, right? 1 for X components, 1 for Y components, 1 for Z components. You would find the values of lambda and mu from 2 equations, put that in the third equation, and that will give you the value of A. And then you can find the position vector of the point of intersection as well. Again, it does not look that difficult, and I think none of you have asked about it as well. Yeah, okay. So first part is pretty straightforward. Given a set that the angle is this, find the 2 possible values of A. Okay, do you want me to do this? Should I do this last question, or should we move on to the next paper? Do you guys want me to do this last question? Okay, let me do this very quickly. Okay, I'll do this very quickly, and then we'll move on to the next paper. 2 lines have these equations. Given that the lines intersect. Okay, so what I'll do is I'll do it very quickly, okay? Given that the 2 lines intersect, find the value of A and the position vector of the point of intersection. Now, how do you start? First of all, write this in column vector form. That makes things easier to understand. The first equation is R equals 1, 2, 1 plus lambda into A 2 minus 1. That's the first equation. And then the second equation is two 1 minus 1 plus mu into 2 minus 1, 1. You have to equate them, right? Because you're looking for the point of intersection. Just equate these 2 equations. How do you do that? Simplify them. It becomes 1 plus lambda A, 2 plus 2 lambda. I have to write it like this instead. 1 plus A lambda, and then 1 minus lambda. This should equal 2 plus 2 mu, 1 minus mu, and minus 1 plus mu. You get 3 equations from that. This is equation number 1. equation number 2, equation number 3. Solve any two of them simultaneously. You would get the values of lambda and mu from them in terms of A and only A, in fact. There's only one unknown there. Yeah, in terms of A, you'll get lambda and mu. Let's do that. 1 plus A lambda equals 2 plus 2 mu. And then 2 plus 2 lambda equals 1 minus mu. All right. Okay, now let's make one of the variables the subject here. I think it's going to be easier if we make mu the subject from the second equation. That will give us mu equal to 1 minus 2, which is minus 1 minus 2 lambda. Put this in the first equation. And that gives us 1 plus A lambda equals 2 plus 2 into minus 1 minus 2 lambda. Minus 1 minus 2 lambda, 2 plus 2 into this. Yeah, that looks okay. 1 plus A lambda equals 2 minus 2 minus 4 lambda. And we have minus 4 lambda. Let's take lambda terms to the other side. A lambda plus 4 lambda. Bring 1 here. That becomes minus 1. We want to find the value of lambda, right? So you can take lambda common. Make that the subject. So lambda into A plus 4, that equals minus 1. And the value of lambda turns out to be minus 1 over A plus 4. Put that in the other equation. We get the corresponding value for mu. Mu equals minus 1 minus 2 into minus 1 over A plus 4. Let's see what this turns out to be. Minus 1 plus 2 over A plus 4. You can take LCM if you want, or just leave it like this, and that's okay. These are the values that we're getting for lambda and mu. All right. Okay. Now, if the lines intersect, what that means is the values of lambda and mu that you found here, they should satisfy the third equation as well, because only then the lines intersect, otherwise they would be skew. They have given that the lines intersect, so the third equation should also satisfy these values. Let's put these values in that third equation. What's that third equation? 1 minus lambda equals minus 1 plus mu. This is your third equation. Let's put this here. 1 minus 1 over A plus 4, that equals minus 1 plus 2 over A plus 4. I've just input the values of lambda and mu here. Now let's simplify this. We get 1 plus 1 over A plus 4, that equals minus 2 plus 2 over A plus 4. What I'm going to do is I'm just going to multiply the whole equation by A plus 4. To get rid of the fraction, I can multiply the whole equation by A plus 4, right? The LCM that we've got here. If you multiply the whole equation by A plus 4, that gives me A plus 4 instead of this, plus 1 on the left side. On the right side, I have minus 2 into A plus 4 plus 2. And now simplify everything, and that gives us A plus 5 equal to minus 2A minus 8 plus 2. 3A equals minus 6 minus 5, right? Is that correct? Any careless error you can spot here? I think it's okay. 3A equals minus 11, and the value of A that I'm getting is minus 11 over 3. Okay, does that look okay? Minus 11 over 3, that's the value of A that we're getting. Okay, now it also asks us to find the position vector of the point of intersection. How do you find the position vector of the point of intersection? Now that we know the value for A, we can find lambda and mu now as well. Lambda is this and mu is this. Find any of them and put that value of lambda or mu in either this equation or this equation, you will get the position vector of the point of intersection. All right, so that's what they want you to do now. So what do we get from this? We get lambda equal to -1 over a plus 4. A is -11 over 3 plus 4. Let's see what the value of lambda turns out to be. -1 over -11 over 3 plus 4. And that's giving me -3. So the lambda value turns out to be -3. Okay. If lambda is -3, we can input that either here or here. It's easier to input in the second equation because that does not have any a in it. So let's do that. For that, we needed actually mu. We don't have mu here. Okay, let's put this in the first one. If I put this in the first one, that gives me r equals 1 plus a lambda, 1 plus a, which is -11 over 3 into lambda, 2 plus 2 lambda, 2 plus 2 into -3, and then 1 minus lambda, that's 1 minus -3. The point of intersection turns out to be 1 plus 11, which is 12, 2 minus 6, which is -4, 1 plus 3, that is 4. This is the point of intersection that we were looking for. So there were two things that we wanted to find. One was the value of A, and the other was the point of intersection, the position vector of the point of intersection. These are the two things that we wanted. Okay, let's move on to the next part. Now it says given instead. Given instead means whatever was given in the first part, that is no longer relevant. The first part is not relevant anymore. Okay. Given instead that the acute angle between the directions of the two lines is cos inverse of 1 over 6, find the two possible values of A. Okay, now the two lines look like this. They're saying the acute angle between them, let's call this theta. Theta equals cos inverse of 1 over 6. What that means is cos of theta equals 1 over 6, right? If theta equals cos inverse of 1 over 6, then cos theta equals 1 over 6. And now we use the angle formula. What's the angle formula? A dot B divided by modulus of A into modulus of B. Cos theta equals this thing. Acute angle between the direction of the two lines. That is this. Okay. Now, what are the directions of the two lines? A2 minus 1. Okay. Let's call the first vector A2 minus 1. That's the vector A basically. And then the second direction vector is 2 minus 1 and 1. Let's find their dot product first of all. 2 minus 1 and 1. What's their dot product? A into 2, that's 2A. 2 into -1, that's -2. -1 into 1, that's -1. The dot product is 2A minus 3. What about the magnitudes? Magnitude of the first vector, A2 minus 1. What's the magnitude of this vector? Square root of A squared plus 2 squared plus 1 squared, and that gives us A squared plus 5. That's the magnitude of this first vector. And then we find the magnitude of the other vector. The other vector is 2 minus 1 and 1. That is 2 squared plus 1 squared plus 1 squared. And that turns out to be under root 6. So we've got everything that we need to input in that formula now. We know cos theta is supposed to be A dot B over modulus of A into modulus of B. We can say cos theta equals A dot B, the dot product, that's 2A minus 3, divided by their magnitudes, product of their magnitudes, that is square root of a square plus 5 and square root of 6. And now we know cos theta is 1 over 6. So we get 1 over 6 equal to this thing. Okay, I can write it like this if I want. 2a minus b, this is square root of something, same powers. We can multiply the bases, and that is going to give me 6a squared plus 30 whole square root. And now we need to solve this equation. How do we solve this equation? We can start by maybe cross multiplying. If we cross multiply, that gives us 6a plus 30, 6a squared plus 30. On the other side, we've got 12a minus 18. Now to get rid of the square root, we can square both sides. When we do that, we get 6a squared plus 30 equals 12a minus 18 whole squared, right? This is a minus b whole squared. Don't just put that power 2 on the individual terms. It has to be whole square, okay? Now let's simplify this. It becomes 6a squared plus 30 equals 12a whole squared. What's that? That's 144a squared minus 2 into 12a into 18. That's 432 plus 18 squared, that is 324. Okay, now let's simplify everything. 144 minus 6, that's 138a squared minus 432 times a plus 294 equals 0. Okay, now you can simplify this if you want, but it's not needed as such. You can just put everything in the quadratic formula directly and then write down the answers directly. Minus into minus 432 plus minus square root of minus 432 whole squared minus 4 into 138 into 294 whole divided by 2 into 138. Okay, so this is what we are getting. Okay, so what do we do now? By the way, we haven't used this yet, acute angle. So we might need to take care if we have a problem there. Let me see what we get from this. A equals what? Menu equation polynomial degree 2 138 minus 432 and 294, and that is giving me one possible value, that's 49 over 23, and another possible value which is 1. Okay. With respect to the origin O, the points A and B have position vectors given by OA equals 2i minus j. So we've got one position vector for A, that's 2i minus j. We've got OB, that's j minus 2k. Show that OA equals OB and use a scalar product to calculate the angle AOB in degrees. That's a pretty standard question. आपने सबसे पहले क्या करना है, दोनों के magnitudes निकालने हैं, उनको equal show कर देना है. Let's do that. I generally prefer to write them in vector form. इससे मुझे आसान लगता है, but that's your preference. आपको जिस तरह बेहतर लगे. I'm going to write them in this form, vector form. OA क्या है? That's 2 minus 1. K तो इसके अंदर नहीं आ रहा. That's going to be 0. That's one vector. The other vector is OB. What's that? That is I term nahi hai yahan pe. That's going to be 0. J is 1 and K is minus 2. ठीक है? दोनों के magnitudes निकाल लें. OA का magnitude. What is that going to be? Square all terms, 2 square plus minus 1 square plus 0 square. And that's going to give you something. That's going to be square root of 5. OB का magnitude निकाल लें. That's square root of 0 square plus 1 square plus minus 2 square. ये आपने step show करना है, because उसने show करने के लिए कहा है कि equal है, तो आपने step show जरूर करना है. This gives you square root of 5, and then you say OA length is equal to OB length. ये हमने prove कर दिया. That was the first thing. अच्छा, दूसरा उसने क्या कहा है? Calculate the angle AOB in degrees.
एंगल AOB चाहिए। इस एंगल का हमारे पास एक ही फॉर्मूला होता है इसके अंदर, वेक्टर्स के अंदर, राइट दैट डाउन ऑन द साइड। ये फॉर्मूला शीट में दिया होता है, cos थीटा इक्वल्स A.B ओवर मॉडुलस ऑफ A इंटू मॉडुलस ऑफ B। इसमें फॉर्म डिफरेंट लिखी होती है, उसमें इस तरह लिखा होता है A.B सब्जेक्ट होता है और ऐसे लिखा होता है। यू कैन जस्ट रीअरेंज दैट, क्योंकि आपको एंगल फाइंड करना है, cos थीटा को सब्जेक्ट बना दिया। ठीक है, तो हम क्या करेंगे, हम यहाँ पे लिख देंगे cos थीटा इक्वल्स A.B। अच्छा, अब यहाँ पे आपने ध्यान रखना है, उसने क्या कहा है, आपको चाहिए एंगल AOB। यू नीड द एंगल AOB। एंगल किस पॉइंट के ऊपर आ रहा है, एंगल आ रहा है आपका पॉइंट O के ऊपर। ये O है, ये A है, लेट्स से ये B है। या तो आपने वेक्टर्स यूज करने हैं दैट आर बोथ पॉइंटिंग टुवर्ड्स O, या तो आप AO और BO यूज करेंगे, या फिर आपने वेक्टर्स यूज करने हैं दैट आर बोथ गोइंग अवे फ्रॉम O, OA OB। इन दोनों में से कोई कॉम्बिनेशन यूज कर सकते हैं। आप ये नहीं कर सकते कि एक का आप OA ले लें, दूसरे का आप BO ले लें, दैट इज नॉट गोइंग टू वर्क। या तो दोनों वेक्टर्स O की तरफ जा रहे हो, उनका हेड O के ऊपर हो, या दोनों O से अवे जा रहे हैं, उनकी टेल O के ऊपर, राइट। इन दोनों में से कुछ भी ले सकते हैं। हमारे पास ऑलरेडी OA OB है, तो उन्हीं को यूज कर लेते हैं। हम क्या कहते हैं, OA और OB का डॉट प्रोडक्ट डिवाइडेड बाय द मैग्नीट्यूड्स। व्हाट्स द डॉट प्रोडक्ट, कॉरेस्पॉन्डिंग टर्म्स को मल्टीप्लाई किया, 2 into 0। ये आपको शो करना है प्रोसेस इसका भी। डोंट राइट डाउन द डॉट प्रोडक्ट डायरेक्टली, राइट डाउन द इंडिविजुअल टर्म्स लाइक दिस। उसका एक फायदा ये है कि आपकी अगर कोई एरर होता है, आपको वर्किंग के मार्क्स मिलेंगे। अगर आप डायरेक्टली लिख देंगे और एरर हो जाता है, यू नॉट गेट मार्क्स फॉर वर्किंग। ये डॉट प्रोडक्ट आ गया डिनोमिनेटर में। OA और OB के मैग्नीट्यूड्स वी हैव ऑलरेडी कैलकुलेटेड देम बिफोर, दैट्स स्क्वायर रूट ऑफ 5 एंड स्क्वायर रूट ऑफ 5। ठीक है, लेट्स इवैल्यूएट दिस। मेरे पास क्या आ जाता है, I'm getting 0 and then -1 and 0. Yes, that's -1/5 cos theta equals -1/5। ठीक है, यहां से मेरे पास एंगल आ जाएगा, इसका इनवर्स ले लें। अगेन नेगेटिव आ रहा है, अगर नेगेटिव होगा तो आपने ऑब्ट्यूज एंगल लिखना है, पॉजिटिव होगा तो आपने एक्यूट एंगल लिखना है, बिकॉज दो लाइंस के दरमियान में एंगल है ना। तो या तो आप ये वाला एंगल देते हो, तो सॉरी, दो लाइंस के दरमियान में नहीं है, इट्स बेसिकली लाइक दिस, इस तरह से एंगल है, या आपके पास ये एंगल आ रहा है। ये एंगल कभी भी एक पॉइंट के ऊपर 180 से ज्यादा नहीं हुआ करेगा। 180 से ज्यादा हो नहीं सकता। अगर आप इसको किसी भी और तरह करो तो वो दूसरी साइड से 180 से कम हो जाएगा। फॉर एग्जाम्पल इफ आई टू ड्रॉ इट लाइक दिस, तो इसमें ये वाला एंगल ठीक है 180 से ज्यादा बन रहा है, लेकिन ये वाला तो 180 से कम है, सो वी कुड गिव दिस एंगल देन। तो ये एंगल हमेशा 180 से कम होएगा। इसका मतलब ये है फर्स्ट क्वाड्रेंट में आपको पता है पॉजिटिव होता है कॉस, सेकंड में नेगेटिव होता है। तो अगर पॉजिटिव वैल्यू आती है तो आपने एक्यूट एंगल दे देना है, नेगेटिव वैल्यू आती है आपने ऑब्ट्यूज एंगल दे देना है। इसमें बहुत ज्यादा आपको क्वाड्रेंट्स वाले लगाने की जरूरत नहीं है, बस आप नेगेटिव आ रहा है कैलकुलेटर से आपको वैल्यू डायरेक्टली मिल जाएगी, cos इनवर्स ऑफ -1/5 you are so I'm getting अच्छा रेडियंस में क्या है मैंने, let me change that into 180 divided by pi. Yeah, so this is giving me theta equals, उसने डिग्रीज में कहा है तो you have to give your answer in degrees. रेडियंस में देंगे तो मार्क कट जाएगा। It's going to be 101.5 degrees. ये आपका एंगल आ गया। इसमें एटलीस्ट 1 डेसिमल प्लेस देना होता है डिग्रीज के अंदर। डिग्रीज में आपने 3 सिग्निफिकेंट फिगर्स नहीं करना, एटलीस्ट 1 डेसिमल प्लेस लिखना है। आपने उसकी इंस्ट्रक्शन दी होती है ऊपर, इफ यू रिमेंबर, एंड द क्वेश्चन एंड ऑन द फर्स्ट पेज उसने कहा होता है 1 डेसिमल प्लेस फॉर एंगल्स इन डिग्रीज। दिस इज द मिनिमम रिक्वायरमेंट, एटलीस्ट 1 डेसिमल प्लेस। 1 से ज्यादा हो सकता है, 1 से कम बिल्कुल नहीं हो सकता। ठीक है, सो कीप दैट इन माइंड। दिस टर्न्स आउट टू बी 101.5. Yeah, so that's the angle. Okay. Acha, Samir, to answer your question, how do we understand that they're talking about magnitudes here? अगर वो वेक्टर की बात कर रहा होगा ना, you will have these arrows there. You see those errors? अगर arrows नहीं लगे हुए, that means we're talking about magnitude here and not vector. ठीक है? Arrows नहीं लगे हुए तो magnitude की ही बात कर रहे हैं. Okay? All right, let's move on. Let's move on to the next question, next part. Now it says the midpoint of AB is M. The point P on the line through O and M is such that PA ratio OA. Yeah, that's the second part. Midpoint of AB is M. The point P on the line through O and M is such that PA ratio OA is square root of 7 ratio 1. Find the possible position vectors of P. Okay, that's the last part. अब इसके लिए it's generally going to be easier if you can just draw a rough figure. That might help just for your own understanding. हम कहीं भी 1.8 मार्क कर लेते हैं. अब of course it's not going to be accurate because हम 3 dimension की बात करें, 3 dimension को हम यहाँ पे accurately draw तो नहीं कर सकते. But just for understanding, let's say A यहाँ पर है, एक point B है कहीं पे इधर. इन दोनों का midpoint is M. That's the midpoint. Now the point P on the line through O and M, O क्या है? O is the origin. So O is the origin. That may be somewhere here. Let's say this is the origin. इस लाइन के ऊपर जो origin और M से पास कर रही है, इस लाइन के ऊपर there is a point P such that PA and OA, उनकी जो ratio है, that is square root of 7 ratio 1. Find the possible position vectors of P. Okay, अब ये P point कहाँ पर है? We don't know where that is, but जहाँ पे भी है, इस line के ऊपर ratio जो बन रही है PA और OA की, what is that? That is square root of 7 ratio 1. That's what we're given. Now that looks quite complicated, but if you have drawn a figure, and let's mark P somewhere, we don't know कि वो कहाँ पर होगा, कहीं पे भी mark कर लेते हैं. Let's say it's somewhere, I don't know, PA का distance ज़्यादा है, P से A का distance ज़्यादा है, और origin का A से distance कम है. So let's say ऊपर कहीं जाके यहाँ पर भी होगा. That's one possibility. हो सकता है यहाँ पे ऊपर हो, नीचे भी हो सकता है, कहीं पे जाके, इधर भी जाके हो सकता है. But let's just mark one point, और उससे देख के हम इसको इस पे सोचने की कोशिश करते हैं. Now, how do we think about this? अब point P जो है वो line OM के ऊपर lie कर, तो हम सबसे पहले क्या करते हैं, point P का कोई position vector निकालने की कोशिश करते हैं. How do you do that? सबसे पहले हम क्या करना पड़ेगा, आपको M का position vector निकालना पड़ेगा. Right? M is the midpoint of AB. सबसे पहले क्या करें, M का position vector निकाल लें. M is the midpoint of A and B. How do you find OM? OM find करना है सबसे पहले. That's the first thing that we need. ठीक है, इसके लिए क्या कर सकते हैं, if you think of the diagram here, we can go from the point O to A, O से A पे चले जाएं, और फिर A से M पे चले जाएं. Right? That's one path that we can follow here, OA and then AM. So that's what we do here. We say OM equals OA plus AM. अच्छा, OA तो हमें पता है, OA क्या है? OA was 2 minus 1 0. 2 minus 1 0. What about AM? AM क्या है? AM is essentially half of AB. AM is half of AB. तो इसके लिए हम लिख लेते हैं half of AB. अब AB क्या चीज है? AB तो हमारे पास आ सकता है आराम से. AB is going to be OB minus OA, right? AB क्या होएगा position vectors की terms में? OB minus OA. Let's figure that out. AB. Let me just calculate that here and then I'll take it there. AB is going to be 0 minus 2, that's minus 2. 1 minus minus 1, that's plus 2. 1 plus 1 हो जाएगा, 2 हो जाएगा. Minus 2 minus 0, that's minus 2. ये मेरे पास vector AB आ गया. ठीक है. This is the vector AB. I can actually just input it there. -2, 2 and -2. Let's evaluate this. 2 minus 1, ये मेरे पास आ जाएगा 1, -1 plus 1, that's going to be 0, 0 minus 1, that's going to be -1. OM vector सबसे पहले आपने निकाल लिया. This turns out to be 1, 0, -1. ठीक है, ये पहली चीज आ गई. अब हमें क्या करना है, क्योंकि पॉइंट P इस लाइन के ऊपर लाई करता है. कौन सी लाइन के ऊपर? OM के ऊपर. तो P का जो पोजीशन वेक्टर होगा वो इस लाइन की फॉर्म का होगा, राइट? इनफैक्ट an easier way of thinking about this could actually be, क्योंकि इक्वेशन निकालने की जरूरत नहीं है, अगर आप निकाल भी लेंगे उससे भी आपके पास वही आएगा. But you can think of it like this as well actually, क्योंकि ये ओरिजिन है. OM और OP aren't they parallel to each other? आपने पोजीशन वेक्टर ऑफ P निकालना होता है, अगर wouldn't that be parallel to this thing OM के, उसके parallel होएगा. तो हम क्या कर सकते हैं, हम कह सकते हैं जो OP है हमारे पास, OP क्या होएगा? OP is going to be parallel to OM. Remember parallel vectors में क्या होता है, हम एक वेक्टर को दूसरे का स्केलर मल्टीपल लिख सकते हैं. So we can say OP is equal to K times OM, right? Because parallel vectors है ना, तो एक को दूसरे का स्केलर मल्टीपल लिखते हैं. अब K की वैल्यू ऑफ कोर्स हमें नहीं पता, लेकिन हम स्केलर मल्टीपल इस तरह से लिख सकते हैं. What does that become now? OP वेक्टर क्या बन गया? OP वेक्टर हमारे पास बन गया K times OM, that's K into 1, 0, -1. That gives me K, 0 and -K. This is the vector OP. एक हमने ये निकाल लिया, OP vector आ गया. Once we've got the OP vector, now it's going to be relatively easier to think about this. उसने कहा distance PA और distance OA, इनकी जो ratio है, that is square root of 7:1. Okay. Now, what about PA distance? ये कैसे निकलेगा? हमें पहले PA vector निकालना पड़ेगा. Let's find the vector PA. Vector PA निकाल लें. PA vector, that's going to be OA minus OP. That equals OA क्या था? It was 2 minus 1, 0. Subtract from that OP. OP is K, 0 minus K. And that gives us something. That gives us 2 minus K, -1 and plus K. ठीक है, ये हमारे पास आ गया वेक्टर PA. PA वेक्टर आ गया. OA वेक्टर तो हमारे पास पहले से, उसका इनफैक्ट मैग्नीट्यूड भी हमें पता है पहले से, दैट्स स्क्वायर रूट ऑफ 5. अब हम वो रिलेशनशिप यूज करते हैं. उसने क्या रिलेशनशिप दिया हुआ था वहां पे? उसने कहा है PA रेशो OA, इसको हम फ्रैक्शन फॉर्म में लिख सकते हैं रेशो को. वी कैन से PO और OA की जो रेशो है वो क्या है? स्क्वायर रूट ऑफ 7:1. so that's square root of 7/1. that's just going to be square root of 7. PA का मैग्नीट्यूड क्या है? Let's figure that out. It's going to be square root of 2 minus K whole square, right? First component का square plus -1 square plus K square divided by the magnitude of OA. OA क्या है? This is OA 2 minus 1, 0. इसका मैग्नीट्यूड हमने पहले ऊपर निकाला भी हुआ है. That's square root of 5. आप वो डायरेक्टली यूज कर सकते हैं if you want, या आप दोबारा निकालना चाहें दोबारा निकाल सकते हैं. But it's going to be square root of 5. That equals square root of 7. And now we can just solve this equation. यहाँ से 2K की वैल्यूज आएंगी, वो हम यहाँ पे इनपुट कर देंगे OP वेक्टर के अंदर. Let's do this. Square root of 5 को राइट पे मल्टीप्लाई करने पहले जाके लेफ्ट साइड को एक्सपैंड कर लेते हैं. We have 4 minus 4K plus K square. ये ब्रैकेट को एक्सपैंड कर लिया. You got +1 plus K square. Square root of 7 into square root of 35. That's square root of 7 into square root of 5. That's going to be square root of 35. दोनों साइड्स को स्क्वायर कर लिया, स्क्वायर रूट खत्म हो जाएंगे. What do we have on the left side now? We've got 2K square and minus 4K plus 5. That equals 35. ठीक है, दोनों साइड्स को स्क्वायर कर दिया. दोनों साइड को स्क्वायर कर दिया तो स्क्वायर रूट्स खत्म हो गया हमारे. Now we've got this thing. It's a quadratic equation. 2k square minus 4k minus 30 equals 0. That gives us k square minus 2k minus 15 equals 0. Can we factorize this? 15 ka factors 5 और 3 use कर सकते हैं. They're going to work. K square minus 5k plus 3k minus 15 equals 0. You get two factors from this, k minus 5 into k minus 3. That equals 0. Let me think about it again. K plus 3, not minus 3. K minus 5 and k plus 3, दो factors आ गए. इससे हमारे पास दो k की values आ गई. K equals 5 and k equals minus 3. ये दो k की values आ गई. उसने two possible position vectors कहा हुआ था ना? नहीं, two तो नहीं कहा था, लेकिन उसने possible position vectors of p कहा था. So we are getting two values of k. अब हम क्या करेंगे? ये दो values of k आई हैं, जो OP का position vector था उसमें जाके input कर दें. We knew that OP was, let me just do that here now. OP position vector was k0 minus k. एक दफा इसमें k की वैल्यू 5 इनपुट कर दें, एक दफा इसमें k की वैल्यू -3 इनपुट कर दें. जब 5 इनपुट करेंगे आपके पास एक पॉसिबल पोजीशन वेक्टर आ जाएगा. That's going to be 5 0 minus 5. When you input k equals -3, you're going to get -3 0 and 3. These were the two possible position vectors of p that we were looking for. ये हमने फाइंड कर लिया. ठीक है, उसने कोई स्पेसिफिक फॉर्म तो नहीं कहा हमें यहाँ पे. उसने सिर्फ पॉसिबल पोजीशन वेक्टर्स का है. So that's what we get. अगर ij के फॉर्म में कहा होता उसमें हम कन्वर्ट कर देते, but this is okay. This is your final result.